All right, today we are looking at lesson 2, day 1 of the unit 2. We're going to look at solving absolute value equations. So just to warm up, to remind ourselves about absolute value, the absolute value of negative 6 is 6, of course. The absolute value of 3.5 is 3.5. And the absolute value of negative 4 minus 8, that's going to be the same thing as the absolute value of negative 12. And of course, that is 12. So, a reminder, what absolute value is. Absolute value is the distance away from 0, and it's always positive. We can't have a negative distance. That doesn't make any sense. So because the distance can't be negative, an absolute value can't be 0, or can't be negative. So it's always just how far away from 0 that number is on the number line. All right. So as we solve an absolute value equation, it's a 4-step process. And we have to do all 4 steps because there's a procedure to do this. And if you don't follow the steps, then you mess up the procedure and you may end up with a wrong answer or even maybe 2 wrong answers. All right, so the first thing we're going to do is we're going to isolate the absolute value. All right, so we want to get the absolute value by itself on one side. We wanted to get everything off of that one side except for the absolute value itself. Then we're going to write 2 cases, a positive case and a negative case, and I'll explain that in a moment. And then we're going to solve each case separately. And then finally, we're going to check our solutions for extraneous solutions. And we'll talk about what that means shortly as well. So, we're going to solve, first of all, 2 times the absolute value of 5x plus 1 minus 9 equals 4x plus 17. Okay, so the first step is we want to isolate the absolute value. So we're going to treat this absolute value as if it's the thing that we're trying to get by itself. So what's being done to it, we need to undo. Right now, it's being multiplied by 2 and subtracted from it 9. So first thing we're going to do is get rid of the minus 9. So we're going to add 9 to both sides. So we have 2 times the absolute value of 5x plus 1 equals 4x, and then 17 plus 9 is 26. Then we're going to divide both sides by 2 to get rid of that 2. So we have the absolute value of 5x plus 1 equals 2x plus 13. All right, so now we're going to set up a positive and a negative case. We're going to have 2 different equations. So we're going to set up a positive case. 5x plus 1 equals 2x plus 13. Now remember, absolute value is distance from 0, so there's 2 values that would make this absolute value true. The positive version, which is 2x plus 13, and the negative version. So 5x plus 1 equals negative, and we're going to put this in parentheses, 2x plus 13. Now, first thing, of course, we need to do is distribute that negative. So that becomes 5x plus 1 equals negative 2x minus 13. Then we're going to add 2x to both sides. To make that 7x plus 1 equals negative 13. Then we're going to subtract 1 from both sides to get 7x equals negative 14. And then we're going to divide both sides by 7 to get x equals negative 2. And then we're going to solve this other one separate. So I put a little squiggly line there to make sure I don't cross over when I'm doing my calculating. Here, of course, we're going to subtract 2x from both sides to get 3x plus 1 equals 13. We're going to subtract 1 from both sides to get 3x equals 12. And we're going to divide both sides by 3 to get x equals 4. So the final step is we're going to check our solutions. We're going to plug each of these numbers in to our original equation to make sure that it makes this sentence true. All right, so first we'll try 4. So 2 times the absolute value of 5 times 4 plus 1 minus 9 equals 4 times 4 plus 17. All right, so we will follow the order of operations. 5 times 4 is 20, and 20 plus 1 is 21. 4 times 4 is 16. So now the absolute value of 21 is 21, so 2 times 21 is 42. And 16 plus 17, that is going to be 33. And 42 minus 9 is also 33. So that checks out. 4 is a good answer. Now we're going to do the same with negative 2. So 2 times the absolute value of 5 times negative 2 plus 1. Minus 9 equals 4 times negative 2 plus 17. I'm going to put a line there to make sure I don't get those confused. All right. Follow the same order of operations. 5 times negative 2 is negative 10. Negative 10 plus 1 is negative 9. All right, negative 9, or 2 times, or the absolute value of negative 9 is 9, and 2 times 9 is 18. And negative 8 plus 17 is 9, and 18 minus 9 is 9. So that checks as well. So we have 2 good solutions. X could be 4, and X could be negative 2. So both of those answers are correct. All right, so now we're going to look at example 2. One thing I want to remind you, notice on the first equation, before we move on to example 2, whenever I looked at the negative case, I put parentheses around the right side and made the whole thing negative, which means I distributed a negative to both the 2x and the 13, so that made the 2x negative and the 13 negative, because they were both already positive. In this one, the absolute value is already isolated, so I can set up my 2 cases. So I'm going to have x plus 10 equals positive, which is 4x minus 8. And I'm also going to have x plus 10 equals the negative. So that's going to be 4x minus 8. So when I distribute that negative, that makes the positive 4x negative, but it makes that negative 8 positive. So that becomes negative 4x plus 8. So just wanted to make sure you were careful on that. All right, so now we can go ahead and add 5x to both, or add 4x to both sides to make 5x. And then subtract 10 from both sides. Get 5x equals negative 2. And then divide both sides by 5 to get x equals negative 2/5. On this side, we can subtract an x from both sides to get 10 is equal to 3x minus 8. We can add 8 to both sides to get 18 is equal to 3x. Then divide both sides by 3, and we get that x is 6. So now I'm going to plug both of those in to our original equation. So I'll start with 6. Absolute value of 6 plus 10 is equal to 4 times 6 minus 8. 6 plus 10 is 16. 4 times 6 is 24. Absolute value of 16 is 16. 24 minus 8 is 16. So that's a good answer. So x could be 6. And then we'll do the same thing with the negative 2/5. I know some of you are freaking out because there's a fraction, but it's okay. You're going to be all right. Fractions are numbers too. All right, so that's negative 2/5 goes in the parentheses. Negative 2/5 plus 10 is going to be 9 3/5. If you wanted to, you could call that 48/5. And then here, 4 times negative 2/5 is negative 8/5. And negative 8/5 minus 8 is, let's see, that is going to be negative 9 3/5. All right, so 9 3/5, and this is going to be negative 9 3/5. Those are not the same. So, let's see, make sure that we did this right. Yeah, we did. So, this is what we call an extraneous solution. This does not check. So, this answer here, this is why we check our answer, is extraneous. All right, so negative 2/5. The math on when we solved the equation worked out correctly. Just making sure. Distributed the negative to both of them. I added the 4x to both sides to make it 5x. I subtracted the 10 from both sides. 8 minus 10 is negative 2. Divided both sides by 5. Yeah, I did all the math on solving the equation right, but when we plugged that in to our original equation, we came out with the negative, right? So we don't have the absolute value. So because of that, it's an extraneous solution. So we don't want that one. So the only good answer there is 6. All right. So now we'll look at another example. Absolute value of 4x plus 7 plus 10 is equal to 2. All right, so the first thing we're going to do is isolate the absolute value. So we got to get this thing by itself. So to do that, we're going to subtract 10 from both sides. We get the absolute value of 4x plus 7 equals negative 8. Now, we need to hold on our second because I was just told, and I just told you, that the absolute value is always positive. So how can the absolute value of something be equal to a negative number? Well, it can't. Absolute value is always positive. So anytime you end up in a situation like this, where you've isolated the absolute value and you've set it equal to the other side and the other side is negative, we can throw that out. It is not going to work. Think about it. There's nothing you could plug in for x that after you take the absolute value of that number that you've multiplied with 4 and added 7 to, that becomes a negative number because absolute values can never be negative. So because of that, we call that the empty set. So we write it like that. There's no number for x that could ever make that equation true. So that's how we write that. All right, in other words to say that is no solutions. All right, so you could say it either way. You could say x equals the empty set, which is a 0 with a line through it like that. Or you could say no solutions. Either way is acceptable. You just have to write one or the other. Don't say x equals 0. It's not 0. It's the empty set, which means that there's nothing that can make it true. All right, so a few more examples here. You'll do this one in class if you haven't already. I'm going to isolate the absolute value. So we got 3 times absolute value of 4x minus 11 equals 9x plus 12. And then we're going to divide both sides by 3 to isolate that absolute value. So we get absolute value of 4x minus 11 equals 9 divided by 3 is 3x. 12 divided by 3 is 4. All right, so now we are going to make a positive and a negative version of that. So we have 4x minus 11 equals 3x plus 4. And then we have 4x minus 11 equals negative version of that. So negative outside of 3x plus 4. All right, so it doesn't matter the order you solve it in, just keep them separated. We can subtract 3x from both sides. So we get x minus 11 equals 4. Add 11 to both sides. You get x equals 15. And then distribute that negative. At 4x minus 11 equals negative 3x minus 4. Add 3x to both sides. You get 7x minus 11 equals negative 4. Add 11 to both sides. You get 7x equals negative 7. So you end up with x is equal to negative 1. So now we'll plug that in. 3 times the absolute value of 4 times 15 minus 11 plus 1 equals 9 times 15 plus 13. Okay. So 4 times 15 is 60. 9 times 15 is 135. $60 minus 11 is 49. And 135 plus 13 is 148. And 3 times 49, the absolute value of 49 is 49. 3 times 49 is 147. And 147 plus 1 is 148. So 15 works. Now the other number, negative 1. So 3, absolute value, 4 times negative 1 minus 11 plus 1 equals 9 times the absolute value of negative 1, negative 1 plus 13. So 4 times negative 1 is negative 1, negative 4. Negative 1 times 9 is negative 9. All right, negative 4 times 11. That is going to be negative 15. Negative 9 plus 13. That's going to be 4. 3 times negative 15 is negative 45. And negative 45 plus 1 is negative 44. Well, that's not the same thing as 4. So that doesn't check out. Let's make sure that we did our math right. Let's see, we have 4x minus 11 equals negative 3x plus 4. So we distribute the negative, add 3x to both sides, add 11 to both sides. Okay, that's where I messed up. That's where I messed up right there. So we got to go back. We messed up. I messed up. So I'm adding 11 to negative 4. That's positive 7. Oh, sorry, let's see, that's negative 4 still. Adding 11 makes that positive 7, so x is positive 1. So let's try that. Sorry about that. 3 times absolute value of 4 times 1 minus 11 plus 1 equals 9 times positive 1 plus 13. All right, let's try this again. 4 times 1 is 4. Nine times 1 is 9. 4 minus 11 is negative 7. Nine plus 13 is 22. 3 times, or the absolute value of negative 7 is 7, and 3 times 7 is 21. And 21 plus 1 is 22. That is much better. So that is a good solution. So that's why we check our answers, to make sure that we did our math right. Sorry to take you on that rabbit trail, but you got to see in live action why we check our answers. All right, so example 5. We want to isolate the absolute value. First step, we're going to subtract 3x from both sides. So that cancels out that 3x on the right. So we have negative 5 times the absolute value of 7x minus 2 equals 10. Then we're going to divide both sides by negative 5. Absolute value of 7x minus 2 equals 10 divided by negative 5 is negative 2. Now, and we have an absolute value equal to a negative, so we know right away there is no number that x could be that would ever make this true. So we're going to say that x is equal to the empty set, or we could say that there are no solutions. All right, that is it for today. If you have any questions, as always, email me or send me a Canvas message. Have a good one.